Hey, welcome back to the office. Patrick Safer here with Digitized Designs. We're back today taking a closer look at the Scantech SIMSCAN, the newest and also smallest scanner in our lineup. We recently did an unboxing and sort of first look at this guy where we took some quick scans with it, but now it's been out for a few weeks and we've had the chance to really get it in our hands and feel out what it's good at, what it's bad at, strengths and weaknesses. And we're ready to take a deeper dive with you into what you can expect from this new piece of hardware. The first thing I can say about the SIMSCAN is that at its core, it's still a professional grade, target-based blue laser scanner, and so it's good at the same things you'd expect that type of scanner to be at. It's got exceptional accuracy. It's really good at handling hard to scan surfaces like dark and shiny things. Transparent still has trouble with naturally just because of the nature of light, but dark and shiny crushes it. The only feature you're really lacking when you compare this to the bigger, more expensive Scantech scanners like the XB11 or the K-Scan Magic is the onboard photogrammetry. That said, it's still more than capable of holding its own when you try to scan larger objects with it, and it's even possible to combine this with one of Scantech's standalone photogrammetry devices should you want to add that functionality down the line. The strengths unique to the SIMSCAN are really two simple things. It's fast and it's small. It captures data at a rate of up to 2,020,000 points a second. It weighs about half a kilogram, just about 1.25 pounds. Fits in one hand. It's about half the size of most comparable handheld 3D scanners. In addition to the convenience factor, just being light, easier to scan with for a long period of time, the size is actually a performance benefit too. Without getting too technical into the why, the optics being closer together on the front actually mean that this scanner is just that much better at seeing into holes and other occluded areas, enabling it to measure parts of some objects that we've actually found impossible to reach with other scanners. All that said, there's nothing left to do but do some scanning. We're going to scan a few of our typical test parts, and then we're going to look at some footage of an application we use this device in, where the small size and the agility of it really allowed it to shine in a place that other scanners would have really had some trouble. So if you've ever seen any of our YouTube videos or you've ever gotten a demo from us, there's a chance you've seen us scan this part. It's got a lot of cool mechanical features on it. It just makes for a really good test part. And it's what we'll be scanning first with the SIMSCAN today. Just using the standard scanning mode, the blue laser crosses. And we're just going for a general purpose mesh you could use for anything from reverse engineering to quality control to visualizations, 3D renderings, anything like that. Just all the above, really. So as you can see, 2 million plus points a second, and the small stature allowing us to see a little deeper into those holes makes quick work of a part such as this. Another common test part for us is the shiny exhaust tip. It's practically mirror polished chrome, which is something we like to use to see how well scanners handle really shiny surfaces. So we certainly scan this with other scanners, and we found actually that the SIMSCAN is unique in that we can get through it in one setup with this hardware. Meaning, with other scanners, we've got to do this in two positions. Scan it like this, flip it over, and scan it from the other side. But the small size of the SIMSCAN means it can see a lot deeper on the inside here, and we're able to get all the way down inside of there, all from this one position. We're getting a little bit of noise, something typical when you're scanning something really reflective like this, and it's all going to get cleaned up when we stop, and Scan Viewer automatically filters. And when we run one instance of remove disconnected components. So here's that filtering step. We see a lot of that noise disappear. Take care of the rest of it with one of these remove disconnected components. And you see we got all the way down inside of there, all the way down to the floor. So this part's finished. So like I imagine every 3D scanning company does, we keep all of our office appliances covered in targets. So I have easy access to this microwave as a really quick, accessible thing to show you how this handles dark and shiny surfaces. The reason that front looks a little weird is there is a layer of glass, and some part of that front door is completely transparent, which is always going to cause trouble for anything light-based. But as you can see, aside from that transparent bit here in the middle, the rest of this poses no challenge for the SIMSCAN. Now the filtering to get rid of a little of that noise. And there's our data. Just to show you one more mode you can scan with the SIMSCAN with. We're going to scan this little pocket knife using the ultrafine mode. The blue parallel laser lines just allows for a little high resolution capture. It's a mode you've seen before if you've seen any of our videos or had a demo of the XP11 or the K-Scan Magic. There's similar functions on those. This enables scanning up to a resolution of 25 microns. The same with those other scans. We'll stop and let the automatic filtering process run. Let's take a look at our data real quick. So I'll go ahead and do one of those disconnected components. The final scan we'll look at today is of the dashboard, steering wheel, and driver's side door of my car, scanned with the SIMSCAN while sitting in the driver's seat of said car to make for somewhat cramped quarters. Like we mentioned earlier, this is a place where the small size of the SIMSCAN proves to be particularly advantageous, as it allows you to get that much closer with the scanner and still pick up good data, even where space to place the scanner is at an absolute minimum. Like places up against the windshield, behind the steering wheel, places like that. We'll time-lapse most of this, but we'll let you watch the rest of this scanning, and then we'll close things out. Thanks as always for attending. Hope you enjoyed it. I'll answer any questions submitted now, but if you have anything you think of later, you just want to contact us for anything else, feel free to call or email or reach us through our website, digitizeddesigns.com. Thanks again and have a great day.
All right, guys, I hope you enjoyed that. If anybody has any questions, you're welcome to put it in the chat now. And I'll go ahead and start. You can also personal message in the chat too. I've already got a couple questions here. What is the accuracy of the scanner? The SIMSCAN is accurate to 20 microns. That's its 3D point accuracy. And the volumetric accuracy is 40 microns per meter. And another one is how big of an object can you scan? General rule of thumb, I tell people for kind of a good part size range is down to the size of a coin, maybe a dime, all the way up to the size of a vehicle. You could technically go larger, but that would be a big scan for this scanner. Kind of that sweet spot, I would say, is probably 6 foot and smaller, but yeah, you can absolutely do a full car. Once you get into the full car size, that's when the photogrammetry really comes in to really help, and so the K-scan or axe might be a little bit better choice, but the SIMSCAN can absolutely handle a full car. How big is the scanner? It is very small. It's about the size of your hand, so just over a pound, and the case is extremely small too. I personally actually flew out to Arizona recently, last week, with it for a scan job, and it was much easier to travel with than some of our other scanners, just from a carry-on perspective. All right, what are all the dots on all the parts? Those are the targets. Those are the reflective targets that the scanner is using for its to locate itself while it's scanning. It needs to see 4 targets in its field of view at any given point in time for it to keep its positioning. Now that said, it uses that during the scanning and the raw scan data portion. If Patrick had finalized and meshed these scans, those dots do disappear. They get hole filled like they were never there. How was this scanner compared to the bigger one that has a laser line as well? Forgot his name. I think you're referring to the Axe B11 and the K-Scan Magic. Both of those are bigger, have slightly larger field of views, and have built-in photogrammetry. They all have a single laser line scanning mode, and the SIMSCAN does as well. We actually did not cover that in this webinar, but it has the single laser line too. Patrick did touch on this one. The SIMSCAN does get into deeper pockets and holes a lot easier than some of the other scanners, just because it is smaller and those cameras on the scanner are closer, so it allows the scanner to see deeper. And that same principle applies to the single laser line mode too. It can actually get even deeper in those pockets than, say, the K-Scan Magic or the Axe B11. Looks like we got another question on precision. So again, accuracy is 20 microns. That's the 3D point accuracy. And then the volumetric accuracy is 40 micron over a meter. Oh, clarification. I see. Precision of the Axe B11. Axe B11's accurate to 20 microns as well, but it has built-in photogrammetry. So without the photogrammetry, you're at 40 microns. With the built-in photogrammetry, if you use the scale bars that come with it, that's included as part of the calibration kit, then it's 35 micron per meter, or if you get the longer reference bar, it's 25 micron per meter. Does it come with its own measuring software, and what does it look like? So yeah, short answer is yeah. So the scanning software that it comes with is ScanViewer, and ScanViewer has not only do you collect and process the raw scan data, but it has some basic inspection capabilities where you can import a CAD model and do some comparisons right inside. It is not a full-blown inspection package, but you can definitely do some basic inspection. It even has some basic GD&T capabilities as well. And then it does have some basic, very basic reverse engineering capabilities where you can extract prismatics and planes and things like that too. The price compared to the Axe B11, it's a little bit cheaper. It's about $5 grand cheaper than the Axe B11. 5 or 6 grand cheaper. What kind of file does the software use or output? Yeah, so you can export several different mesh or point cloud options. So typically the most common export is going to be an STL, but you do have STL, OBJ, PLY, and then on the point cloud side, there's a .asc, a text file, and then I think there's one more option, but STL is definitely the most common. It does work with all the inspection softwares, Geomagic Control X, Polyworks. You can technically import an STL into SolidWorks, but SolidWorks isn't great at handling scan data, so that's when we recommend like Geomagic for SolidWorks or some of the other plugins. So the question on MSRP, if you want to know the price, we can get you a quote. Email us directly at info@digitizeddesigns.com. We'd be happy to get you a quote and get you pricing on scanners and software. I can't say it publicly just because of vendor rules. But yeah, we'll be happy to get you a quote if you're interested. Just let us know. Any other questions? These have been some good questions so far. How many targets does it come with? It comes with, in the box, I think 4,000 of the 6mm targets. Those are just your standard targets that you see used in the video. There are also 1,000 of the 3mm targets that can be used for smaller objects or more intricate objects as well. What other accessories do I need out of the box? Um, Pretty much. It comes with everything you need. If you're scanning smaller parts, sometimes a turntable is nice, but you don't need a special turntable or anything. We've got a wooden turntable that we made. We also have some like $10 turntables that we get off of Amazon that are plastic that work great too. And you don't need targets. If you have a small part and you scan it on a turntable, you can put targets on the turntable and not have to worry about putting targets on the object, which can be nice sometimes. So yeah, it comes with everything you need right out of the box. And then of course we also offer training on everything. So we'd get you up to speed. Anything else? Is there a difference in scanning black and glossy black? With like a matte black scans a little bit faster. That both of them with this scanner with the SIMSCAN scan great. Not all of our other scanners can handle even matte black or definitely not shiny black, but the SIMSCAN does great with both matte black and shiny black. Shiny black, you do need to typically turn the exposure of the laser up just a little bit more than you would with matte black, and then it scans fine. but there's controls on the scanner, so you can actually do that real time while you're scanning. So you don't have to stop or anything during a scan. Can the Axe B11 do shiny black? Yep. So the SIMSCAN, the Axe B11, and the K-Scan Magic all can do shiny black very well. They all have used that base technology of the blue lasers that does very well on the dark and shiny surfaces. Here's another one. What was the red, yellow, green while scanning on the left side of the screen? That was your distance meter. So the green is the middle of the depth of field, and then red and yellow means you're either too close or too far away. And the nice thing is, if you get too close, it's not like you're going to collect bad data. If you get too far away, you're not going to collect bad data. If you're either too close or too far, it just stops recording. And there is an indicator on the scanner itself too, so you don't always have to be watching the screen to know if you're within a good distance. So you have to put dots on everything you scan. Not necessarily. So if you have smaller parts that are on the turntable, you can put dots or targets on the turntable itself. The scanner just needs to see 4 targets at any given point in time for it to keep its positioning. So if you can put them on the background like the turntable, then you don't need to put targets on the object. If it's a larger object, yes, you do have to put targets on the object. So there's a little bit of setup time there, but the targets are nice because it does make it very objective on if you have enough features for registration while you're scanning, and it guarantees that accuracy. About temperature, does that affect it? So just calibrate in your working environment, and then you should be fine. It comes with the calibration board. Calibration takes about 5 to 10 seconds, depending on how practiced you are. But yeah, just calibrate the scanner in your environment, and then you'll get good, accurate data. Anything else? Guys, well, it looks like that's probably it for today. If anybody has any additional questions, feel free to email us at info@digitizeddesigns.com. We'd be happy to answer any additional questions, set up a demo, talk about pricing, all of it. So just let us know. Thank you again for jumping on our webinar today, and we'll talk to you later. Thanks.